All right, the next 4 problems all involve determining whether something is a function or not. Okay? And a function is a relation in which every element of the domain gets mapped to the one and only one element of the range. That's the definition of a function. So first off, a function is a relation. Does anybody know what a relation is? Anybody?
Have something in common.
What?
Something that's together.
Something that's together, not so much.
In common.
Okay. A relation is a way of saying how x values get paired up with y values. That's what a relation is. In order for something to be a relation, every x value has to be paired with a y value. If it isn't, then it's not a relation. If it's not a relation, it can't be a function. So basically what we want to do here to determine if something's a function or not, number 1 is determine if it's a relation or not. Does every domain element lead to something? If I put something in, do I get something out? That makes a relation. For it to be a function, each domain element can lead to only one range element. So if 1 goes to 2, only 2, nothing else but 2, and 2 goes to 5, and only 5, and nothing else but 5, that's what a function looks like. If 1 goes to 2 and 3, now it's not a function. So that's basically what we're looking for here. And the types of functions we're going to see are going to be mappings, which is the first 3 examples, and sets of ordered pairs. Another type of function you've seen so far, another type of relation you've seen so far is graphing. We graph some lines. Those are relations. Equations are relations. Sometimes they're functions. Okay. So, example 5. What this is a mapping. What it's telling us is how to create ordered pairs. Y gets paired with P, A gets paired with X, M gets paired with X, M gets paired with 5. That's what it means. So another way of writing that exact same thing would be a set of ordered pairs. Y comma P, A comma X, M comma X, M comma 5. Okay, the domain is what we're putting in for X, the range is what we're getting out for Y. So when you're looking at a mapping, they're just basically showing you a picture version of a set of ordered pairs. Okay. The arrows show you that this domain gets mapped to that range, creating an ordered pair X comma Y, or in this case Y comma P, whatever. All right. So in order, first of all, to be a relation, in order to be a relation, every single domain element has to be going somewhere. There has to be an arrow coming off of it. So if you were to see this, let me just give you an example real quick of what would not be a relation. If you saw that, now it's not a relation. Because what does Y go to? Nothing. Y is part of the domain, it's going to nothing. So that would not be a relation at all, so now it's not a function. All right, taking a look at this one, how many things does Y go to?
1.
1. How many things does A go to?
1.
How many things does M go to?
2.
2. Okay, so going back to this definition of a function. Every element of the domain gets mapped to one and only one element of the range. And M goes to how many?
2.
2. So this is a no because M goes to 2 things. Use my best mathematical terminology there. M goes to 2 things. That's what makes it not a function. 2 ways to make it not a function. Number 1, it's not a relation. Number 2, something in the domain goes to more than one thing. Either one of those would be the reason. If you get a no on these problems, I want to know reason. If you get a yes, just write yes. But if it's no, say no because of this. All right, so no because M goes to 2 things. The end.